Hello friends, in this video we will continue our examples on Newton's second law and we will see how to calculate apparent weight in case of an accelerating elevator. So what is apparent weight? So apparent weight is a weight that you feel when you are inside an elevator. Let us suppose we have this elevator. And when this just starts its motion from zero velocity and it starts going in the upward direction and you are inside this elevator, you will feel an extra weight. So this weight that is felt by you is basically apparent weight. You can measure this weight. What you can do is you can put a balance or bathroom scale inside your legs and you just stand up on that balance. And whatever the reading of that balance will be, that is your apparent weight. Basically in that case what happens, you have this balance and you are trying to push this balance in the downward direction. And the same way this balance also try to push you in the upward direction. So this normal reaction, that is the reading of this balance, is the apparent weight. So now in this video we will basically derive a general expression for calculating the apparent weight. In this case there are four possibilities. One possibility, you have just started and going up and you have just reached at the top and this elevator is coming to rest, and then in next case if you are coming in the downward direction, and then finally you are coming to the ground floor. So we will discuss four cases. So let us discuss these four cases and we will basically derive expression for apparent weight in all these four cases. So these four cases are, in the first case, let us say elevator is going down. So this elevator is going down. So this has just started from the top floor. So on the top floor it was in the zero velocity and it has started to going down. So what will happen? It will try to increase its acceleration. So velocity is in the downward direction and in this case acceleration is also in the downward direction. Now let us suppose that this has reached to the ground floor, and once it has reached to the ground floor, that is case number 2, in this case this has just reaching to the ground floor, so velocity is just still in the downward direction. But what about acceleration? So this lift has to come to rest finally. So this has to decelerate. Basically it has to decrease its speed. So it will experience a deceleration. In other words, it will have acceleration in the upward direction. So velocity is in the downward direction and acceleration is in the upward direction. So this is your case number 1, this is your case number 2, and this is your case number 3, when the elevator has just started from ground floor and it's want to go to the top floor. So what will happen? Velocity now is in the upward direction. What about acceleration? So this just started as zero velocity, it has to accelerate, it has to increase its speed in the upward direction. So this way we can say acceleration is in the upward direction. Now final situation, this has just reached to the top floor. So what will the velocity direction? Again velocity is in the upward direction because this lift is going in the upward direction. But it has to come to rest. This means it has to decrease its speed. So it has to have a deceleration. So this means velocity is in the upward direction, but the acceleration in this case will be in the downward direction. So this is acceleration. Now there are four cases. We want to calculate basically apparent weight for all these four cases, and the idea is very simple. We have to draw the free body diagram and then we have to apply Newton's second law. So let us discuss all these four cases. First we will draw the free body diagram and then we will calculate the normal reaction, and normal reaction is nothing but the weight, that the force that this moment is applying over this balance, and similarly this balance is also applying a normal reaction to this moment. So let us draw free body diagram of this moment. So what are the forces that is acting on the moment? one force that is acting is its weight, that is mg, and the balance is applying a normal reaction in the upward direction, and this is normal reaction. Now in this problem, let's say if I assume that the positive direction is the upward direction, that is my sign convention. So this is the sign convention, that is the upward direction is the positive direction. So let us write Newton's second law. So in the force in the upward direction is normal, that's why it's positive. mg is in the downward direction, so we have to write its negative sign, that is minus mg, that is total forces in the y direction is equals to n minus mg, and now I have to equate this. Force is equals to mass into acceleration. So mass of this moment is m, and acceleration is in the downward direction, that is in this direction, and I have assumed that positive direction is the upward direction. So in this case, acceleration is again negative. So from here I can calculate normal reaction, that is nothing but mg minus ma, or I can write this is nothing but m times g minus a. So this is the normal reaction in this case, and this is the apparent weight that this moment is going to experience. So you see, apparent weight is less than mg. So you are basically subtracting something from mg minus ma. So apparent weight normal reaction is less than mg. So she will feel little bit lighter in this case. So when the lift is coming down and this is accelerating in the downward direction, something like from the top floor, you will feel little bit of less weight of yourself. This is the apparent weight less in this case. Now let us consider situation 2. So in this case again, we have to draw free body diagram for this moment. So let us denote this moment using a point. What are the forces that is acting? mg is acting in the downward direction, and normal reaction is acting in the upward direction in this case again. So this normal reaction is acting in the upward direction, and acceleration is in the upward direction. So now I can write equation of motion, that is n, that is positive, mg is negative because this is in the downward direction, is equals to mass times acceleration. Acceleration is upward, and we have assumed that the upward direction is the positive direction, that is my sign convention for this problem. So from here I can write n is equals to mg plus ma, or I can write this is nothing but n is equals to m times g plus a. So you see, in this case, the moment is going to experience more force, or she will experience more weight. So apparent weight in this case is more than the actual weight. So for downward journey, when you just started from the top floor, you will feel lighter. But when this is coming to the ground floor, you will feel heavier. So this is for downward journey. That is, you are coming from top floor to the ground floor. So when this just starts its motion, you will feel heavy. You will feel lighter. And when this is coming to the rest, you will feel heavy. Basically, you can experience this whenever you are in the lift or you are in the elevator next time. Now let us consider situation 3. What are the forces acting? Once again, normal reaction and mg in the downward direction, and normal reaction is in the upward direction, and acceleration is in the upward direction. So this situation is same as this situation. So you can write Newton's second law, that is n minus mg is equals to ma. So in this case again, n is equals to mg plus a. So you will feel little bit heavy in this case again, because this is accelerating in the upward direction. Basically what happens in this case, lift is trying to push you, and that's why you feel heavy. Lift is trying to push you, and you also have to remember the acceleration of lift and acceleration of this moment is same, because both are having the same acceleration. So this is a single system. This moment is not flying in the upward direction or going in the downward direction. So we can say acceleration of elevator and acceleration of moment is same, and that is a in this case. So you see, when this is in the ground floor, either it's just coming or it's just going from the ground floor. In both cases, you will feel heavy and the apparent weight will be N is equals to mg plus A or mg plus ma. Now this situation, that is situation number 4, is same as situation number 1. Now you can write Newton's second law in this case once again. Let us first draw free body diagram. Mg is in the downward direction, normal reaction is in the upward direction, and acceleration in the downward direction. So we can write N minus mg is equals to mass time acceleration, and acceleration is in the downward direction. That's why you have to put a minus a, because I assume that the positive direction is the upward direction. So N is equals to mg minus a. So this is the apparent weight that the movement will experience when just reaching to the top floor. So you see, in both cases C will experience basically lighter, and in these two cases C will experience a higher weight or higher weight than the actual weight. So apparent weight is the higher. So we can summarize all this. So when you are going onto the top floor, either you are going onto the top floor or you are coming from the top floor, you are going to feel lighter. So you are going to feel lighter in this case. Now, when you are going to come onto the bottom floor or the ground floor, in that case, either you are going up from the ground floor or you are coming to the ground floor, you are going to, your apparent weight will be more than the actual weight, and you will feel yourself heavy. And this is because in this case basically lift floor is trying to push you, and that's why you feel yourself heavy. So this is bottom floor. So in this video you have seen how to calculate apparent weight in case you are inside an elevator, and I will say whenever you are in the elevator next time, try to experience this. So when you are coming from the top floor, you will feel yourself lighter, and when you are coming to the ground floor, you will feel heavy. And the same thing when you are going to the upside, that is from first floor to the 10th floor. Let's say this is a 10th story building. On the first floor you will feel heavy, on the 10th floor you will feel yourself lighter. Remember, only acceleration happens at the ground floor and at the top floor. So as this elevator lifts, this elevator basically accelerates only at the ground floor or at the top floor. It can accelerate or it can decelerate depending upon in which direction you are going. But in the middle, elevator moves with a constant velocity. So remember, that's why you don't feel apparent weight in the middle of the journey. Don't feel apparent weight. You only feel apparent weight, change in the weight at either it is coming to the rest or it has just started to the motion. I hope you enjoyed this video, and if you enjoy, please share with your friends and like and subscribe. You can also comment in the section, and I will see you in the next video. Thank you.